Okay, yeah. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. Yeah.
Waalaikumsalam. Good afternoon, sir.
Yes. Shall we continue? Yeah. Our topic. Hopefully, this is the last day for. The last meeting for for us talking about the sample theorem. Yes. So, as for reminder, yeah, why we study the sampling theorem? Why we study sampling theorem? Since first, given the population here, populations, and then we sample the data from the population. Yeah, this data, let's say x1, x2, x3, x4 until xn. This is the population. Why we sample? Because we want to know information about the populations. What kind of informations? Yeah, actually, yeah, we can know information about the mean of populations, the variance of populations, and then if we know there are two population axes, so then we want to know the differences between mean 1 and mean 2. Yeah. And then because of limited number of sample, we need study how the mean compared to the standard deviation behave, yeah, or behavior of mean and standard deviations. And then sometime if we have two populations, but we don't know about the mean of the population, but we only want to know the differences between two population, and then we can use comparing standard deviation 1 compared to the standard deviations 2. And as we know that this variable, this information, yeah, actually this information is taken randomly. So we can say that those information is random variable. Because of random variable, then we can derive the probability distribution model. And then what kind of model, what kind of probability distribution model? The probability distribution model is depend on the number of sample. Yeah, number of sample. If the number of sample greater than 30, and this is less than 30, and we can classify as normal in general, yeah. But if the norm n is less than 30, this is not normal, not normal. Okay. Okay, and then after we know the probability distribution, actually what is the purpose, what is the benefit of knowing probability distribution? By knowing probability distribution, we can measure how big the chance, measure the chance how to say, dengan mengetahui probability distribusi, kita bisa menghitung seberapa besar kemungkinan parameter yang sudah kita duga. How to say in English? I don't know. By knowing the probability distribution, we can measure how much the chance that our conjecture, our hypothesis is true, we can measure, or we can compute how much the probability, how big the chance that our hypothesis is true. How much? And then if we say in our conjecture or in our hypothesis say that maybe this mean of population is some value, certain value, and then we want to check, we want to validate, based on the evidence, based on the sample that has been taken, and then how much the probability based on the sample. And based on that value probability, we can conclude, we can conclude that our hypothesis is correct or not. Nah, something like that. Yeah. Okay. How about the story here? What I'm telling just now. Everybody understand? Or any questions before we continue talking what inside in the table?
So sir, basically this is used to to validate if the hypothesis that we make is correct or not, like our hypothesis about mean, about variance, and other parameters. Is it like that?
Yes, correct.
Oh, okay, sir.
Any other question, please? Anyway, you already seen my screen, right?
Yes, sir.
Okay,
Yes, sir.
Okay. Any other question, please? If no, okay, let's continue talking what inside in this table. Yeah. Okay. 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 You can see from the table actually consists of 4 columns and left blank or blank column 1 at the right. Yeah. The first column is population parameter that we want to know. And then the second column is how to formulate the random variable. And the third column, what kind of distribution that we can model. Yeah. First, for second row in here, we want to know the parameter that we want to know is mean of the populations, and then we make observation by taking n number of sample, by taking n number of sample, but here we should point out that the number of sample at least 30 to follow that this random variable follow normal distribution. Yeah, the how to say the number of sample each of observation should be at least 30. Okay, and then after that we get the what we get the random variable. Actually this mean is random variable, and then this is from population, this is standard deviation from population, and this is the number of sample, and then we got the random variable z, something like that. Yeah, and then this x given from central limit theorem, this x is normal random variable with mu equal to mu of population and standard deviation of yeah, the standard deviation is actually this is divided by n, yeah? Divided by population of random standard variance of population divided by n, yeah, for the standard deviation x. And then by forming this variable z, actually this variable z, this random variable z is normal, yeah. Z is normal with mu equal to 0, and then the standard deviation of z here equal to standard deviation population divided by n. Okay, yeah, this is normal. If z, we are talking z, the standard deviation, the probability is with mu 0, and the standard deviation of z is being like this. How about this one and this one is belong to the x bar? Okay. Is there any questions? Is that clear?
Sir, so the standard deviation is standard deviation of population powered by 2 divided by the number of sample that we take for the Z distribution.
Yes.
But the mean is the same like the population, or is it 0? I still don't understand.
The mean is wait a moment. This one is already should be 1. Okay. Okay, maybe I will a bit revise to make more clarity. Yeah, actually, wait a moment. with this is mu z equal to 0. This one is minus by mu. Okay. Z equals to 0. For this one, Z equal to 1. Yeah, talking about the distribution of random variable, this one is a normal with mu is 0 and standard deviation 1. But when we're talking about the distribution of let's say distribution of x bar, distribution of x bar is normal with mu x bar, ya, mu x bar, ya, mu x bar. So I need to put here x bar equal to mu populations with and the standard deviations is, yes, then what sigma kuadrat x bar berarti, ya, x bar. Maybe it's more clear. Equal to sigma pangkat 2 dari P dibagi berapa? Dibagi N, ya, dibagi N. Okay, I hope it is clear. Yeah, for the Z is normal. X bar also normal. The Z normal with mu equal to 0 and standard deviation of Z is 1. And X, how about the X? X is also random variable and the distribution is also normal if n greater than 30 with mu x equal to the mu populations and standard deviation of x is equal to standard deviation of population divided by number of sample. Yeah, something like that. Okay. From the first row, is there any questions?
Sir, what is the difference between x bar and the Z?
Okay, what is the difference between Z and X bar? Is that correct?
Yes, sir.
Yeah. X actually the average from the data we taken. For example, like this. For example, we have we want to sample the temperature today, yeah, temperature today, and we use 30 thermometer, yeah, 30 thermometer. So, for example, we taking the data This is from thermometer 1, this is from thermometer 2, and this is thermometer 3 until thermometer 30. And then we got the X is just average of X E n divided by n. That's the X. Actually, maybe the value is around 35 degrees Celsius. How about the Z? Actually, Z is the number can be the Z, because this is, let's say, 35 minus maybe the mean population is given 36, and then the standard deviation population might be 1, and then this is 30. So it is possible to have Z value being negative. But if the direct measurement, I mean X bar is the result from direct measurement, there is no possible for being negative value. So actually, if we draw the probability distribution like this, and this is the 0, and this is the 0, and this is the probability value. This is the probability around mu X bar, and this is the probability of Z. So it's like shifting, shifting from the real probability to the standard normal. Standard normal is when we talk, when we say the probability is standard normal if the mean is 0 and standard deviation is 1. Something like this. So can you imagine this one?
But why the standard deviation become 1?
Why the standard deviation is become 1? Yeah, I know what you asking. Because every value Z here has been divided by this value, sigma population divided by the square root of number of sample. Actually, this is the normalization, right? Means that the value of Z become normalized. Normalized, it means that the standard deviation is become 1. Is that answer your question or no? Or getting more confused?
So we like shift the graph of the x bar so that we can get the negative value, and then the standard deviation is divided by the standard deviation of population divided by root of n, so that it become 1. Is it like that?
Yes, it's become 1. How to say? Yeah, it's kind of, if you don't divide it by this value, and then the standard deviation of z still n. If you don't divide it by this value, and then the standard deviation of z is still equal to this value. You got it? That's why we need to normalize, so that's the new, let's say z1 like z way z, yeah, because for given x standard deviation is till n. Or okay, maybe I will expand maybe more sequentially. Okay, wait a moment. Okay. Let's say the green one, the green distribution, this is for probability of x bar. The x bar with mean equal to mu x, and the standard deviation of x bar equal to n. Until this point, do you understand? Until this point?
Yes, sir.
Okay, and then we want to define a new variable. Let's say it's like a modification of x. Let's say y. Y is x e minus mu x. Okay. So the result of distribution y, it's going to be shifting right to the left. Means that there is a possible for y having negative value and also positive value. And then because of that, we can shift this graph to the left until this point. Okay.
Yes, sir.
Yes. How about the standard deviation y? Can you determine standard deviation? Sorry, I mean variance of y. Variance of standard deviation is almost equal. Yeah, the variance of y.
After it shifted, or?
Yeah, after it shifted. Actually, y is already shifted.
Is it still the same like the x?
Still same, yeah?
Yes.
Okay. Agree, yeah? Everybody, yeah? Or any question? Standard deviation, I mean, variance of y is still variance of x bar, and then still variance of populations divided by number of sample. Until this point, okay?
Yes, sir.
Yes, yeah. And then we modified again the z. Z actually x bar minus mp divided by sigma p per n. Actually, this is xp mean, yeah, the sigma x, but this is standard deviation, yeah, standard deviations, yeah. So because every value has been divided by its standard deviations, yeah, so the variant of z, become 1. Is it okay?
Yes, sir.
Yes. So it's clear now?
Okay, sir. Clear, sir.
Okay, good.
Thank you.
Okay. Okay. I hope this row is clear. And then how about the second row? Second row are for example, the difference of two mean. It's meaning that for example, we have two populations, and the interested informations that we want to know is how differ, yeah, how differ of each mean of the populations, ya. Jadi sejauh mana bedanya rata-rata populasi 1 dan populasi 2. Loh, ini gunanya untuk apa, Pak? Ya, for example lah ya. The case is like yesterday, we want to know whether the some pain A and pain B has same trademark, so same quality or same production factory, ya. Jadi kita ingin tahu sejauh apa sih bedanya dari dua produk ini. Kalau kasus kemarin itu mengetahuinya misalkan dengan waktu pengeringan, ya, waktu pengeringan. Kalau waktu pengeringannya sama, ya kira-kira cat ini mempunyai kualitas yang sama atau mempunyai merek yang sama, gitu. Kalau waktu pengeringannya sama. Nah, kalau waktu pengeringannya berbeda, oh berarti kemungkinan cat ini beda merek, gitu kira-kira. Nah, given that this information that we want to know, and then we derive the difference between two mean, yeah, the difference between two mean, and then because the each mean is how to say, is random variable. This is a random variable and this is a random variable, and then the difference between them also, let's say we can say is y or gamma. This gamma also random variable. And then how about the and then we can formalize, we can write this gamma as z because this is a random variable. What kind of random variable here is X bar, it means that mean from first population. This is the mean from second population. Actually, it's taken from the sample, but this is a given population 1, and this is a given population from 2. And then a combination of two standard deviation or two variance, and then we can compute thing like this. And again, I will make a revision again here. For Z, this is the mu Z, yeah, mu Z is still 0, yeah. Wait a moment. Alah. 0, but how about this one? Is this one for the distribution X, yeah? Distribution X is normal, yeah, yes, distribution of, actually not distribution X, but distribution X1 minus distribution, let's say distribution Y lah. Distribution Y with the Y is equal to this one. X bar 1 minus X bar 2, something like that. Nah, is normal with, yeah, with mu of X, yeah, this is actually mu of Y, yeah. This is mu of Y. And this is sigma of Y. Something like this. Okay. I hope it is still phenomena, but the information that we want to know is difference mean from two populations. Okay. Any question?
Hello, sir.
Yes.
For the we're on the second one, right? The difference of two mean.
Yes. The second one.
Is there like any example of problem for this one, like the difference of two mean? Is it like probably like similar to the yesterday's, but there's two different mean? Is it like that, sir?
Yes. This is yesterday. The application or sample case is yesterday.
Oh, yesterday. Oh, okay.
Yes. Yes.
Oh, okay. Oh, okay.
Yes. Yeah. Actually, we are now summarizing, yeah, what we have learned several weeks, yeah, this week and 2 weeks ago. Not 2 weeks ago, 1 week ago. Yeah. Is there any question maybe still on the difference of two means? Yes.
Sir,
Yeah.
for like the yesterday's problem, like the mean was the same, right? Like the mean of the drying time is equal. But if the mean of the, let's just say, two different subject is different, is there any like difference? Or oh, okay, so the in the formula it would be different number, not 0. Is it like that, sir?
Yes.
Oh, okay, okay.
Okay, we continue. Yeah, we continue our next row. Yeah. Okay.
Yes, sir.
Yeah. Actually, what is the next row? This is the problem is we want to know the variance of the populations. Yeah, we want to know the variance of the population, and then because we concern on the variance, so the variable z is really depend on the variance. Yeah, really depend on the variance here. Variance of the observation actually. Yeah, and again, because the variance as square, yeah, as square is random variable, and then the z is also random variable, the random variable, and the how about here the variance of population? Why we need to divide it by variance of population? Because it is for normalization actually, yeah. And then we realize that the distribution of variable z here is followed by chi square distribution. Chi square, not normal anymore, yeah, not normal anymore, but it's follow chi square distribution with degree of freedom being n minus 1. Yeah, okay. And then how to compute the probability is still same, but we should concern here that the probability distribution is no longer normal but chi square. Okay, yeah. Okay, and then the next is we want to know the behavior of mean and standard deviation of population. So in this case, actually we want to know the mean, yeah, the mean, because the mean is changing, right? The mean is changing, and then the standard deviation also changing, becomes a random variable. You know, the mean, this is the random variable, and then the standard deviation is random variable as well. And then you can see here the nominator here, the q, let's say q is random variable. The q actually is equal to this one, the q, this is q, and this is the denominator here, and that's because of the mean is random variable and the standard deviation is random variable. This model we can apply using T distributions. Why we use T distribution is because the number of sample less than 30, yeah, less than 30. Less than 30, we can use T distributions. And the last one is comparing variance of two populations, and because we only concern on the variance parameter, yeah, so we put here, this is the variance from first observations, this is the variance of the from another observation, but coming from different population. This is population 1, this is population 2. And to compute this behavior, you can see here, wait a moment, actually, you can see, you can see relation between the two random variables. Actually, this is a random variable and this is a random variable, and you can see here the relation. I mean, the interaction between two random variable. This become F distribution that consisting two degree of freedom. One is coming from the first observation. This is from the second observation. Actually, this observation taken from first population. This is taken from second populations. And computing the probability is still same, but reflect or based on the F distributions. Okay, any questions?
Sir, what is the difference between row 1 and row 3? I mean, both used for finding mean, but what's the difference between the first and the third? Is it only difference in the number of the samples?
Row, you mean this mean and this one?
Yes, sir.
Yes, it's depend on the number of sample. Actually, the motivation is like this. I mean, the story is like this. Usually, when we have a large number of sample, the standard, the variance of sample become almost stable. Yeah. So stable is, yeah, we can assume it doesn't change very much. But when we use only small number of sample, it tends to that the standard, the variance of sample is changing. The variance of S is changing. Yes. And because of changing, we should consider that this variance also as a random variable. And then, because you can see from the Z variable, the consequence of the variance become random variable, and then not only the average, not only the average of sample, but also the, how to say, the variance of sample also become random variable. Yeah. Is that clear?
So when the number of sample is large enough, like more than 30, so then the variance is stable, which means for every sample that we take, the variance will always the same. Like, yeah, it's stable. Is it like that? But
Yes.
for n is say less than 30, the variance is also random. I'm like changing. So that's why we use another formula to solve.
Yes. Yes. That's the how to say, state of the art.
Oh, okay, sir. Thank you.
Yes. Okay. Any other question? No. No questions. No questions.
Sir, I have another question, sir.
Yes, yes, please.
For the third row, is there any distribution for the X bar, just like in the first row?
Distribution of X bar, yeah.
Yeah, for the third row.
Yeah. Wait a moment. Yeah, actually, for the expert, what do you mean expert? You mean this is mean or variance?
I mean the distribution of X bar, like in the first row, there is a distribution for the X bar with the mean of mu p, and the variance is the variance of population divided by n. So for the third row, is there also any distribution for the X bar like the first row?
Expert, yeah, I understand. So, in your opinion, I mean, what the meaning of expert here? You mean you say mean or variance?
The mean, sir.
The mean. If
The mean
you
of the sampling, yeah.
okay, if you are asking about the mean, we don't have, it doesn't exist, not exist, not exist. Why not exist? Because the concern is we don't want to know the mean, but we want to know the variance. So it's kind of from the from the observation, we don't compute, yeah, we don't compute the mean.
Sorry, sir. I mean fourth, sir. Sorry. I mean fourth row, not third. Sorry.
For
Yeah.
this one.
Yeah. Sorry.
Oh, okay. Okay. So the mean expert, yeah, the expert here is mean is, can we write as a Q? Is it okay?
Yes.
Yeah, I mean similar, right? Because Q also a function of expert, right?
Yes, sir.
Okay. And if we want to know specifically for X, actually this X we can classify as a normal. As a normal, yeah, but I say we say like a star here. I mean, we can, how to say, yeah, we can say that the x is normal. X is a normal, but we don't put many attention here because the concern is comparison. I mean, not only affected by the X bar, but also the S. Yeah. But I answering your specifically your questions. X bar is normal.
Oh, okay, sir. But there's no, I mean, like, there's no the distribution of it because we're concerning about the X bar and also the variance.
Yes, yes,
Oh, okay, sir. Thank you.
yes. Okay. Any other question? So I want to write some assignment here. Wait a moment. Okay, I have made assignment consists of 3 questions related to this topic. I will post it to the emas, actually combining with the material today. And please conduct the assignment and submit to the emas before the deadline, yeah. Okay, that's all. I think that's the end of this topic about the sampling theorem. And if you have any question, you can ask anytime related to this topic. And then we finish. Thank you very much for your attentions and see you next week. Stay healthy and stay comply with the protokol kesehatan, ya. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much, sir.
Thank you,
Have a
Pak.
good Friday, sir.